I'm Todd Trout. I'm the technical manager here for Trimec Solutions. Yep, and Brad Williamson is here with us with SolidWorks. He is the TTM, or the technical manager for the South area in North America. Brad, are you with us here?
Hey Todd, yeah, I'm just down the road from you in Nashville.
Excellent.
Well, I'm going to kick things off if you don't mind, Todd. And before we jump into the product demo, I wanted to first introduce you to one of our customers, Center for Advanced Design. They're based up in the Minneapolis area. Center for Advanced Design, CAD, they are product design specialists. They what they're known for in their area is being really creative, very flexible, very responsive to their customers. They do everything from product development through manufacturing. Now, they are avid SolidWorks customers of ours. They've been loyal SolidWorks users, but as industrial designers, they also use a lot of other tools. They use other sketching software, they use other surfacing software, just anything that they can that they need to get a job done for a particular client. So we approached them about a year ago to be early adopters of SolidWorks Industrial Design before this product even hit the market. And when we met with them at first, they identified some bottlenecks in their process and some goals that they wanted the software to do for them. Most importantly, they wanted to find a way to accelerate their industrial design development cycle. They wanted to improve their flexibility and streamline communication internally and with their clients. And Mark McCulley is one of the co-owners there. He told us that we kept looking for a better solution for bridging the gap between industrial and mechanical design. Now, we're going to come back to Center for Advanced Design at the end of the presentation, and I want to give you a little update on how they made out with their pilot project. Now, before we began the development of this product, we did a lot of market research. We talked to a lot of our customers who do industrial design and got their feedback. We got their thoughts on how they're currently using software in the industrial design process. We repeatedly heard that they use lots of different pieces of software, sketching, surfacing, communication tools, and those tools don't necessarily talk very well together. They also told us that doing complex modeling in a parametric modeler like SolidWorks, that can sometimes be kind of tricky, take some advanced training and some advanced skills. And everybody we talked to told us that collaboration and communication was sometimes a challenge, and that's especially when we're dealing with companies overseas, maybe for doing manufacturing where our time schedules don't match up, or maybe we even have language barriers. So we took all that feedback and we set out to develop a new application, SolidWorks Industrial Design, something that would be complementary to SolidWorks. We wanted to be able to do a few different things. First of all, to be able to model freely without the CAD constraints of traditional parametric modeling. We wanted users to always be connected to their data so they could access it from any device, any location. And we also wanted to find a creative way that they could harness social media trends and a collaborative type of experience to where the internal and external stakeholders in a given project, maybe the team members, maybe the clients, maybe even the suppliers, could all communicate with each other on a single platform. And finally, we wanted a product that was a complement to SolidWorks, so not yet another disconnected application in that process. So many of our customers gave us a similar feel for what their typical industrial design process looked like, and it was surprising how similar people's processes are. Conceptual design almost always starts with some kind of a hand drawing, hand sketch. That step is probably never going to go away. And the great thing about hand sketching is that it's very low cost. You can try out lots of different ideas on pen and paper, or maybe a piece of software. Now, one or two of those concepts are generally going to float to the top and become the most popular, and then we might commit to a physical prototype, maybe a foam or a clay model, maybe even a 3D print. Probably we'll try to do some kind of a 3D model of that, maybe using some kind of surfacing program to make those complex shapes, but inevitably there's going to be a parametric CAD solution at the end of this for detailed design. We hope it's SolidWorks, and for most of our customers, it's SolidWorks. The challenge to this workflow, though, is that you've got a lot of disconnected solutions on the front end of that process before you even ever get into doing the detailed design. We're using lots of pieces of software, lots of disconnected processes, and so that's what we thought we could affect that part of the program by making one single piece of software that would simplify that workflow. So what we propose to do is accommodate many of those initial steps in that process. So you can do your concept sketching freehand. You can do your freeform modeling, even some parametric modeling, but then have a smooth on-ramp into SolidWorks for finishing out that detailed design. So the goal here is a nice smooth workflow, two complementary apps that will talk great to one another and really minimize the set of tools that are involved there.
Thanks, Brad. So in the next few minutes, what we're going to have Brad do is demonstrate this typical industrial design workflow, and he's going to come up with an ergonomic and stylized design for a mouse, for just a normal computer mouse. So he's going to take you through those 4 steps. He's going to spend about 5 minutes at each step along the way. But first, he's going to need to sketch out some ideas, like he talked about, the hand sketching type of thing that was traditionally done. After that, he's going to be able to go and sculpt a freeform shape of those based on those 2D sketches. And then after he has the 3D model, he's going to be able to share that design concept and look for some feedback with a collaborative team. And after that, he's going to be able to refine the details for a production model. The goal of the concept phase then is to answer the question, will it work, and what is the best idea that we can get to move forward before we're investing time in the detailed CAD model. All right, so to get things started, Brad's going to begin the project with some basic ideation sketching. The same kind of thing that you typically do with a paper and pencil or pen, and or maybe a standalone drawing software. Only this time, he's going to use SOLIDWORKS Industrial Designer connected to his tablet to do some freehand sketching in a 3D work environment. Brad, go ahead and show us what you have in mind.
Yeah, I'll be glad to jump in and do that. Now, before I do, I just want to let everybody know what kind of hardware I'm using, since you can't see what I'm doing here. I've got a Dell M6800 laptop, pretty standard workstation caliber laptop, the same kind of machine that you would spec out for SolidWorks. But I'm also using the Wacom Cintiq Hybrid, and this is my my Pen Touch tablet. It also doubles as a display monitor, and that's kind of a nice benefit. So I'll be doing my freehand sketching using the Wacom tablet. Of course, the software needs a Windows computer to run on, and the tablet that will then serve as my secondary monitor. So I'm going to jump in, and I've got a webcam showing my tablet in use here, and you'll see me just start sketching. I'll just use some touch gestures to manipulate the paper in the workspace, and then just use the stylus to start roughing in some hand sketches. Now, I can take advantage of some software accelerators like mirroring and erasing and things like that make it go a little bit faster. Let me split the screen now so you can see sketching in industrial design, and you can also see that the tablet's still in use there. Just rough in the basic shape here. If I make a mistake, I'll just flip the pencil over and it becomes an eraser. Or, like you're familiar with in any sketching software, we can just swipe over some of those strokes and get rid of them. Want to also add in a little bit of detail here where I think the button profile is going to go, and also sketch in what that wheel is going to look like. Just rough in a few more strokes here, maybe scribble a little bit to imply some texture, some shading. Give it a little bit more of a stylized type of a look. That's looking pretty good. So we're just roughing in the shape here, but what I'll do next is change my pen color, change the pen weight, and now I'll come back over those rough strokes with a bit more confident trace strokes here to give it a little bit more form. Now, I'm always sketching in a 3D mode, even though we happen to be projecting on a single plane. That makes it really nice for being able to rotate around and get any kind of view that I want. The tablet is great. It's pressure sensitive, so it's really capturing the feel that I want to capture. Let's see. I'll flip over into a side profile here, and draw another sketch. And what's cool about this is sketches work basically like layers would work in any other kind of a drawing application. So I can have multiple sketches that represent either different positions or even different concepts. Now to get this side profile, I'm just going to draw in some vertical lines, and that gives me some reference locations. Now I'll sketch in the side profile here, what I want that to look like. That's pretty good. I'll kind of rough in what that parting line should be. And then we're going to need a thumb groove on one side. Let's imply a little bit of contour, a little slope there, get rid of some of these mistakes. And then once again, I'll go back to that red pen with a little bit thicker weight and just add a little bit more confident, bolder strokes here. And I also have some sketching aids too. So if I hold down modifier keys like Alt, for example, Alt will snap to perfect arcs and circles, and Shift will snap to perfect lines like you're accustomed to in other drawing software. So we've got now two pretty decent orthographic views. I've got a top view, I've got kind of a side view, and if I rotate out to a little more of an isometric view, it almost looks 3D, even though this is just 2D sketches. And this might be a good starting point just to show to the customer and see if we're going in the right direction.
All right, cool. So, that was just, I got to say, some good sketching and, nice job there on the good-looking mouse, really. But in just a few minutes, Brad's been able to rough out those ideas or those ideation sketches. It's kind of like a digital napkin or maybe a design notebook that you would have. But and if wanted, you could take it a little step further. You could incorporate photos, image files, maybe even some 3D geometry. It's no problem for SOLIDWORKS Industrial Designer. Sketching then is fast and easy, and it means you can quickly capture your ideas and just as important, create multiple concepts. Now, before
Sketches, those are pretty useful, but if we want to really visualize this in 3D, we need to get some kind of a model. Now, what's different about freeform modeling in Industrial Designer versus traditional parametrics is that we don't have to use a lot of complex surfacing. Instead, I'm just starting with a basic shape like this cube. And then I can just manipulate the cube by translating it, scaling it, pushing, pulling, and just watch how quick, with just a minimum number of moves, I can basically get that bar of soap kind of shaped into a mouse. It's going to look pretty cool here. I'm going to use the triad. You'll see me use this triad a whole bunch of times. I'm just going to grab some different control points and push and pull on it. That tool, that one tool, lets me scale, rotate, and translate, all with the same interface. So I don't have a lot of complex tools to learn. Because typically an industrial designer, they're not necessarily a CAD expert. They don't spend all day modeling in 3D. They do a lot of different types of jobs. So we wanted a tool that was easy to use. Now I've got the top view looking pretty good, and everything's nice and C2 curvature continuous. But sometimes we want a hard edge, like where we have a parting line. I want a nice hard edge along the bottom, for example. So I'll just pick on the edges around the bottom of my block and turn on the crease feature. And so the crease just makes it into a nice hard edge. That's great. Now if I look at this in a side view, I want to get that nice beveled type of a profile. So I'll grab that scaling tool right there on my manipulator, grab the parting line, translate it down a little bit, and I want that to have a little bit of a swoop to it. So watch this. I'm going to use this patented tool called Quick Align. Quick Align lets me swipe with my pen here on my Wacom tablet, and whatever I draw, it snaps the freeform control points to my pen stroke. And it stays active, so I can really iterate and try out lots of ideas really fast without having to keep reselecting and going back to the command. So after a few little pushes and pulls on this, I'll make a couple more fine adjustments. And I just continue working my way around the model. Let's go to a side view, grab a few control points, use that manipulator to, I'm going to orient the manipulator here so it's sideways to the screen, and then I'll just scale that in a little bit. There we go. Got a nice taper to it. Drop it down just a hair. Everything is maintaining a nice C2 curvature continuity also, so I've got a great looking aesthetic that's happening there without me even really having to think about it. So I've got kind of an asymmetric design happening here. We want this to be a right-handed mouse. No offense to left-handers out there, but we want it to have a little asymmetric styling here. Just continue pushing and pulling on this a little bit. You can see how I was able to just, with a few moves, get that style kind of matching the hand sketches underneath. Now I need a button or a little thumb groove recess here, so I'm going to turn on a tool called Subdivide. And what that does is takes those larger faces and breaks them up into a series of smaller faces. So it just gives me finer and finer control depending on how many subdivisions I want to make. It's almost like adding control points to a spline. You draw a spline with a minimum number of control points, and then you just keep adding necessary points to give you the fine control that you need. And so just one little subdivision there gives me that ability to take that thumb groove, kind of push in on it a little bit. You see how the curvature is being maintained there? It's got a nice flow to it. I'll turn on some transparency. That way I can see the sketches underneath and make sure that I'm just staying true to that original design language of that underlying 2D sketch. But I'm pretty far along. I could probably continue tweaking this a little bit more and just pushing and pulling on the shape. But this is coming along pretty well. I've done a good job of staying true to my 2D sketches. So I think this is a good point where I'm ready maybe to start pitching this to the customer.
Awesome. I mean that looked really pretty straightforward. You've done it in record time, I guess. I mean it looked so easy. But that freeform modeling tool, it's so cool, kind of like a virtual model shop, right? It was like you had that model of clay that you could just manipulate or push or pull and carve on. So, and then you had the tools though like crease and the patented quick align tool, right? That you could take just about any organic shape, anything you can imagine, and create it without having to be that CAD expert, right? So he said he's ready for some feedback. In this next scenario that we'll set up, he's reached that point, and he wants to get some input from the team before he goes any further. Now, this would typically mean saving screenshots, maybe editing some images, attaching pictures and files to an email, and just on and on. But you're going to do that to start the discussion typically, and that's pretty common. But it involves at least two or more different pieces of software that aren't integrated together. So in contrast, you'll see what Brad can do by starting a private discussion thread and inserting snapshots in his model to share with the client, all without ever having to leave the modeling app.
Yeah, exactly. So many customers told us that communication was kind of a struggle. Live meetings, difficult to get everybody in the same room. Email threads, difficult to keep track of. So why not leverage things that we do every day, like take advantage of social media, for instance. And so we've embedded our own little social media platform right into the modeling application. And by creating these private discussion threads, we can invite whoever we need to this. It might be a client, might be members of our design team, and create a discussion thread. So I can add my comments, attach files, attach media, and now I'm just going to window select and grab a few screenshots of my active workspace. And you see how it just pastes those right in, and I'll just publish that comment. Now all the members of our team are notified, the ones that we've subscribed to this thread. So now you're going to see a little scenario where Mark, one of our collaborators, he's on his Android phone here. He can log right into that private, secure community, and right away he can see my comments, and he can see the images. Optionally, he could even use a 3D viewing app to view the 3D model. So Mark's going to add a couple of comments, and he says he wants to sketch in some details for some finger grooves and some buttons. So I'm going to take a look. I'm still here in the modeling app. I take a look at the comments that he's posted. They're updated in real time, and I'm going to start drawing a sketch for what I think that button layout should be. Now what's unique about this sketch, though, is that I drew directly on the 3D model. The point being here is that in that concept phase, you don't always want to commit to 3D features, to complex modeling, when maybe a 2D concept is all you need. So we combine that 2D hand sketching you saw me do earlier. We now give you the ability to do that directly on the 3D model, almost like having a Sharpie and you're marking up a physical prototype or a 3D print. So I rough in where I want that overmold to be and the buttons, and then just as seamlessly I can grab a snapshot and I can post that right to our design community. Now, Mark can either view that on his mobile phone or he can get back to his PC and log into any browser, log into that secure community, and all of the discussions track right along with any of the members that we've invited to this discussion. So what's going to happen over time is that we're keeping a record of the evolution of the design and the decisions that have been made as this design moves forward. A really great way to consolidate and get away from file shares and email threads and other disconnected types of apps. What do you think, Todd?
Really cool. I mean, again, more tools that are, just really kind of groundbreaking as far as sketching on the 3D model, and having that all in one platform, one environment, right? So, and you said the data's always, the data is always secure and up to date. So when you're doing that design, you're changing quickly, but you can concentrate on working together and not managing those files. So that take that out of the way. The built-in tools that you showed. I mean, it's convenience, right, as far as a platform, sharing feedback, preserving that history as the design goes, and it's going to evolve and get multiple concepts. Now, and the way you were collecting feedback, posting that to the team, getting instantly being able to incorporate those changes, that was pretty cool. And industrial designers combining the tools to design, then share and discuss with your users, and they were on any device. All right, so once we've got the feedback, we're making really good progress. At this point, you could do something like print that in 3D right from SOLIDWORKS Industrial Designer. But let's say the team's happy enough with this concept and want us to go ahead and move and add the manufacturing features. So to do that, I'm going to have Brad open the mouse up in SOLIDWORKS, right, where you can check for manufacturability, add the internal shell and ribs and pockets and things like that, maybe even get him to create the tooling split. When he's done, then watch how, again, he's going to be able to post that progress to the discussion thread.
Yeah, exactly right. So Industrial Designer is a complementary app to SOLIDWORKS because chances are they're potentially two different users. So we've got the industrial design taking place here. I'll save that out, and then let's just open that up in the best parametric modeler on the planet. I think that's SOLIDWORKS. So here comes our model in SOLIDWORKS 2015. It opens up as a beautiful watertight solid. There's no issues like I would have with other disconnected surface modelers where there's translation issues. And now I can take advantage of what SOLIDWORKS does best, and that's detailed design for manufacturability. So I can look at curvature, I can do draft analysis, look at zebra stripes, and study the form, the curvature, test it for manufacturability. This is all looking really good. So I think at this point I'm ready to start designing some tooling features. SOLIDWORKS has a ton of great tooling design features that will help me create the tooling split. It grabs that parting line, turns that into a parting surface. We'll need this to be a hollow part, obviously, so I'll turn on the shell feature. Let's give ourselves about 50 thousandths wall thickness. Turn on the cross section, just kind of drag through that with the section view tool. Looking good, constant wall thickness. Everything is looking like we want it to here. So now I'm happy to use that parting surface and generate the tooling splits. We're going to split it into two bodies. SOLIDWORKS does a great job of this. We've now got two separate pieces. Now I can isolate the top and the bottom. So in this bottom cavity portion here, I'm going to draw in some stiffeners. Purpose-built tools for manufacturability. That's what SOLIDWORKS does best. Let's draw some lines, and this is just going to be a little network of ribs. The rib feature will automatically extend those lines until they reach a boundary. I don't have to worry about it. I just give it a thickness. That's looking good. I want to smooth off those round corners, so I'll just touch that top face, and it'll round every sharp edge on those ribs. About 20 thousandths. Should look pretty good. Yeah, nice. Now, we use a lot of the same types of features in our consumer product design, like battery packs and such. So I've got a little library feature of a AA battery pack. I'm just going to drag and drop that in and then use another one of those specialized features in SOLIDWORKS called the indent feature, which takes that battery pack and it just kind of pushes that into the model and deforms around it. So I've got that tooling feature already built in, looking good. Now let's take a look at the top half. So I need to create a little overmold in that thumb groove region. I'll just sketch up a spline, push and pull on it a little bit. That form's looking pretty good. And I'm just going to use that spline then to project onto that complex curved shape of the mouse. Now once I've got that projection on there, I can take all of those split faces, combine them into one, and I'm just going to use that as an indentation feature. So we'll just cut right into the model. 20 thousandths, 25, something of that nature. Looks pretty good. Tell it the direction I want to go, inward, not outward. There's my 25 thousandths. And that looks pretty good. Now we'll take that exact same shape and I'll just copy that interior surface, and this time instead of cutting into the model, I'll project outwards by 50 thousandths, and I'll make that a separate part. So now we have the indentation for our overmold and we have the overmold itself. I'll isolate that. Let's round off that sharp corner. 20 thousandths or so, 10 thousandths maybe, just real subtle edge break on that, looking good. And now I'll show all of the bodies. We've got the top, the bottom, the overmold. This is effortless in SOLIDWORKS. And then maybe just for a little bit of flair here, we'll create an exploded view. Let's pull out that overmold. Let's grab that and the top, use the handles to drag it up a little bit. And now we've got a nice little exploded view. Looking good. And finally, that same threaded discussion tool that we used in Industrial Designer, that's available to us in SOLIDWORKS too. So I don't even have to get out of the modeling app. I can grab a screenshot right here, maybe even optionally attach an e-drawing or a SOLIDWORKS model, and keep that discussion going as the design evolves, and keep getting feedback. So we'll let our team know that we've made some progress on the initial tooling, see how they want us to proceed.
Wow, so that's just it's the perfect complement to SolidWorks for in the industrial design process. It was great to see how the model seamlessly and perfectly comes back into SolidWorks. You can put those details in. It's just great. So when it's it's time to zero in on those designs, Brad was able to finish it out in SolidWorks. What we have is a seamless workflow from concept to manufacturing. All right, so to review, Brad took us through that basic, typical industrial design to mechanical workflow, right? Began by sketching on some ideas, capturing them in 3D model space. Then he was able to push and pull on that freeform clay-like model, right? Basically the virtual model shop. And then at each design point, as needed, you can post the progress to the private community and gather that feedback without ever having to manage multiple software apps, email threads, all that kind of stuff. And then finally, made a decision, handed the concept off to into SolidWorks, and done the detailed mechanical design. Beautiful.
Hey Todd, I got to interrupt for just a second here. While you were going through the PowerPoint there, I got another comment on the design community.
Okay.
And they actually wanted me to go back to the freeform shape and do a little bit more stylizing on it. So I guess before we finish up, maybe the audience would like to see how we would handle that kind of a change.
Yeah, go ahead.
Okay, so give it back to me. I'm going to jump back into industrial design. It's a lot like Grandpa always said, use the right tool for the job. If we want to modify that original freeform shape, I'm going to go back to Industrial Designer to do that. And it's a lot like if you've ever put an Excel spreadsheet in a Word document. You go to Excel to edit the Excel, and it automatically updates in Word. And that's what I think you're going to see here in just a second. So while I'm talking here, I'll just make a few manipulations like you saw me do before. Grab some of these control points, maybe make the styling a little bit more aggressive, a little more asymmetric, making some of those push-pull modifications. And so this is just like editing that Excel that's within the Word document. Once we are happy with the modifications here, I'm just going to save this out as a version 2 of the industrial design model. Okay, so a little more push and pull, slope that in a little bit more. Mm, pull that up a little bit. And let's see what they think of that. So I'll save this back out into the SOLIDWORKS format, only this time I'm going to call it version 2. Now back in SOLIDWORKS, all I have to do is update that main body. So I'm just going to point to the version 2 model instead of the version 1.
Okay, I was wondering if he's going to have to redo all those steps again.
No, we don't have to redo it because it just swaps out the bodies just like your edited Excel file in a Word document. Now, depending on the nature of the changes, you know, you could make it really radical, and then some of those features might have to be edited. But for the most part here, in this case, all the tooling splits updated, the ribs, the fillet, the battery pack, that stuff all updated. And, of course, there's our explode view. And so that's a really good encapsulation of that workflow, how these two complementary apps work together, and they provide you the best tool for each part of that job.
That's great, Brad. Hey, I mean, let's finish up. We're kind of little over the 30-minute mark or so, but that's cool. We've seen great stuff. If we go back to that customer that Brad mentioned earlier, Center for Advanced Design, they were a small design firm. Their business depends on being fast, responsive to clients, and they needed to find ways to accelerate that industrial design development progress. So with SOLIDWORKS Industrial Designer, they actually measured a 60% decrease in their development process. Now, obviously, you know, your mileage will vary, but you know, even half of that number would be a great improvement. Now, using multiple software tools in the past, it always limited their ability to handle those changes quickly, and they were looking for a better way to streamline that communication with their customers, and they overcame both of those challenges with Industrial Designer. And the co-owner there, Mark, again, if another statement he made to us was that with SOLIDWORKS Industrial Designer, you know, they had everything they needed for their process, from sketching and 7D modeling to surfacing, rendering, without having to jump back and forth between applications. So I think that really really spoke well for their experience. You know, the takeaways here is with Industrial Designer, you can do things faster, you can get your designs done faster, you can do more ideas, more options, and that's going to give you the best solution, because you know, really good enough just isn't good enough. You want the best, and you're going to be able to improve your collaboration and innovate more, and that's the name of the game. All right. Well, that's all we've got. Thanks to everyone that's attended and been with us today. We can check our questions out now if there were any. Just take a look here. All right. I don't see any on the panel there. Do you, Brad?
No, I think they're thoroughly stunned and thrilled.
Well, great. So you guys know how to reach us. We'd love your feedback. Love, you know, if you want any more information or maybe even a follow-up meeting, just let us know. Again, thanks for your attendance, and you guys have a great day.